Okay, here we go. So exciting. Exponentials. Okay, so this is the first part, and we should be so excited. Yay! Anybody know what an exponential is? Like an exponent?
Yeah.
Okay. So an exponential function looks like this. Basically, we'll have a variable as our exponent. So if I wanted to do like a super basic example, we have like y equals 2 to the x power. Okay. So I don't. Okay, I'm gonna say general form. We would have like something like y equals b to the x power. So b is just representing the base, and the base could be anything out there, it doesn't really matter. Okay, but this b value has to be not equal to 1 or 0. Okay, so it could be anything else, it could be negative, it could be positive, it could be a fraction. Yeah, because if it was just y equals 1 to the x power, 1 to any power is just 1, so you have a horizontal line. So it's not really giving any graph of an exponential. Same thing with 0. 0, you just have a horizontal line, so it's not really an exponential. Negative 1. Yeah. Okay. So yeah, we're gonna focus on these. This whole chapter is about exponential logarithms. Maybe logarithms because that's the inverse of exponential. So we'll get to all those other properties later. Okay. So I typed A, I used B up there, it doesn't really matter. But does anybody know the difference between y equals a to a positive x and a to a negative x power? Does anybody know what an exponential graph looks like? Yeah, it's like, okay. So this guy, if I graphed it, I would have a point at 1, because if I plugged in 0 for my exponent, a to the 0 power, anything to a 0 power, is just 1. And that'd be decreasing on the left side and increasing rapidly on the right side. The x value can be 0, 1. It's like the base part can be 0, 1. Yeah. Okay. So that's what this guy looks like. If it was negative. Not always. This is if it's just like a to the x power b to the x. There's more things with it, then that's going to change. And we'll graph with more things with it. Okay. When it's negative x, I still have the first point at 0, 1 for my y-intercepts. Instead, we're going to be decreasing. Yes, I should have gone to that point. So if it's positive exponent, this is technically called exponential growth. And we've heard that word before. And the other one is exponential decay. So we're decreasing. Okay. So if I'm seeing the basic characteristics for these two, y-intercept is always 1. What's the domain for both of these? What does domain represent? The x values. That would be like third range if you think of the y values. The x values, is there anything I'm not getting? Yeah, it should be all real numbers. So that's one way to say it. We talked about interval notation, right? You could write negative infinity to positive infinity. Okay. Hitting every x. The range is what you were saying, right? I'm not hitting every single y value. I'm getting missing some. So what is my lowest y value that I can even cross? 1. But my graph does go below 1 a little bit. I can get into all those fractions. So if I run an inequality, it has to be greater than 0. So I can't ever cross this x-axis for these base cases. Does anybody know what this x-axis is representing? What term it is? Yes, lovely. So those are coming back into play for exponential graphs. Awesome. Okay. Let's graph some things. So we're going to graph both of these. So we have f of x equals 3 to the x power, and g of x equals 5 to the x power. So if I didn't know how to graph anything, we could make a table, which is probably what we should do. So make a table for f of x, and a table for g of x. And what numbers would you like to plug in for x? You plug in 1. Nope. Then let's just do -1. Yeah, you can plug in anything for the x values because the domain is all real numbers. It's like this 3 and the 5. Those can't be -1, 0, or 1. Okay. So if I do -1 here, I would have 3 to the -1st power. Does anybody remember how to work with negative exponents? Yeah. So you write over 1, negative exponents, you move either to the bottom or the top, depending on what's that. So you move it down, so it's now actually 1 over 3 to the 1st power. It's just a third. So what is 3 to the 0 power? 1. And 3 to the 1st is 3. Okay, do the same thing if I'm plugging -1 in for x, for g of x. I have 5 to the -1st, which is 1/5. 5 to the 0 power. Yeah, and then 5 to the 1st is 5. Okay, so just making a graph really quick. Where are my asymptotes located? Okay. So graphing f of x first. So these graphs will look really similar. It's g of x that should be increasing a little more sharply. So increase and become flatter faster. You have the x-axis. It looks like I crossed it, but I didn't. I should do this. So the larger the base is, the steeper it is at the y-axis. Smaller it is, the flatter it is. Yeah. But we know we can plug in points and just plot them. Nothing too crazy. Okay. So graphing those ones, it's not, I don't know, nothing crazy with it. If I write exponentials in standard form, I can do all sorts of transformations to it. So here's the standard form of exponential. We have y equals a times b to x minus h power plus k. Does anybody remember what h and k represent? Yeah, so h was the horizontal shift that you were talking about. K is the vertical shift. Do we remember what he did? Yeah. So if it's positive, my exponential is above the x-axis. If it's less than 0, it's below the x-axis. I'm going to put a restriction on b too. So if b is greater than 1, I'm going to say it's exponential growth. If b is between 0 and 1, exponential decay. So if we change our exponent to positive or negative, that changes it from growth to decay. But if b is greater than 1 or less than 1, that also changes it from growth to decay. Okay, so the main piece that we really need to notice is we should figure out what our asymptote is. So our asymptote typically is at the x-axis, but that'll shift when I have a vertical shift. So if I have a k value, then my asymptote shifts up or down depending on what it is. So this k is the asymptote. And you can write the equation as y equals k if you wanted to and draw it in. So before we weren't adding or subtracting anything, so it's just y equals 0 on the x-axis. So it was like plus 1 would be y equals 1 asymptote for your exponential. Okay. Go on, Greg. Oh my gosh. I think my video is going to end here real quick anyways. I'm going to pause it and restart it. I only have 15 minutes. Well, okay. I thought Trey was going to get his ducks in a row here.